Welcome back to Science Uncovered, everyone. Today, we're diving into the fascinating world of clean energy, specifically, the quest for efficient hydrogen production. Joining me is Sally, a materials scientist, and Matthew, an expert in sustainable energy technologies. Welcome, both.
Thanks for having me, Joanna. Excited to be here.
Likewise. This is a really important area of research.
Absolutely. We'll be discussing a groundbreaking research paper that details the high-throughput discovery of new catalysts for photo-driven hydrogen production. Essentially, they found a way to create a much more efficient process for generating clean hydrogen using sunlight.
That's right. The key innovation lies in their high-throughput experimental setup. Instead of testing catalysts one by one, which can be incredibly time-consuming, they developed a system capable of running 108 reactions in parallel. Think of it like a super-efficient factory for catalyst discovery.
And this efficiency is crucial. Developing effective catalysts for hydrogen production is a huge challenge. The traditional methods are slow and expensive, leaving much room for improvement. High-throughput methods are a game-changer here.
So, what exactly were they trying to achieve? What were they hoping to find?
Their goal was to find better catalysts for the hydrogen evolution reaction, or HER. This reaction involves using a catalyst to split water molecules into hydrogen and oxygen. They were specifically focusing on using sunlight to drive the reaction, making it a truly sustainable process.
And what materials did they use in this study? This is where it gets interesting.
They focused on combinations of copper, iron, and ruthenium. They explored different mixtures of these metals, both in pairs and as a ternary combination, to see which combinations would make the most effective catalysts. What they found was pretty surprising.
Surprising how?
Well, they discovered that certain multimetallic combinations, particularly the ternary combination of copper, iron, and ruthenium, showed dramatically improved performance compared to using just one of these metals or using them in pairs. They observed strong synergistic effects, meaning the whole was greater than the sum of its parts.
Exactly. The combination of these three metals somehow created a much more efficient catalyst than any of the individual metals or the two metal combinations. That's the beauty of these synergistic effects.
It almost sounds too good to be true. Were there any challenges to this research?
Oh yes, there were several. For example, because they were creating these nanoparticles in situ, that means within the reaction itself, they couldn't easily control the precise composition of each individual nanoparticle. They saw a distribution of compositions, making it more complex to understand precisely which compositions resulted in the highest activity.
It also highlights the power of high-throughput experimentation. The sheer number of combinations they tested allowed them to find these unexpected synergistic effects that might have otherwise been missed using traditional methods.
So, what are the implications of this research? How could it change things?
This research has enormous implications for clean energy. The ability to efficiently produce hydrogen using sunlight could revolutionize energy storage and potentially reduce our reliance on fossil fuels. It opens up many new avenues for clean energy research.
Precisely. The high-throughput methodology itself is a significant contribution. The techniques they developed could be applied to discover better catalysts for other important chemical reactions.
This is truly groundbreaking work. Thank you, Sally and Matthew, for shedding light on this fascinating research. Listeners, if you want to learn more, we'll have a link to the full research paper in our show notes. Until next time, keep exploring the wonders of science.